All right, hello. Here we are going to look at the quotient rule in terms of our rules of exponents. So the quotient rule is all about when we have the same base in the numerator and denominator. So that means on the top of our fraction and the bottom. And what we need to do is we need to simplify it to just one base, and that one base needs to have a positive exponent. All right, so when an exponent crosses over the middle line, it changes signs, right? That's about the negative exponent rule, right? When we take the reciprocal, it switches spots in the fraction and changes signs. So here's how it works with the quotient rule. If we think about this in terms of a picture here, x to the fifth is really 5x's multiplying by itself. And if we're dividing that by x to the third, which is really 3x's multiplying by itself, and we take a look at this picture, we can see, hey, these three on the numerator and denominator will just turn into a 1, right? They'll go away, leaving us with just that x squared up top. So that's kind of a picture representation of how the quotient rule works, is we're just simplifying what's on the numerator and on the denominator. And also, in a similar fashion, I know sometimes we looked at it like this. We said, hey, that x to the fifth power, it's larger, and it's going to use its kind of gravity there to pull the smaller term up. Alright, so when we're looking at this here, with my faulty erasing going on, alright, so this smaller term, it's going to move up to the top, and when it gets there, it turns negative. So when we have x to the fifth and an x to the negative third, it gives us our same x squared. Alright, so in a sense, you're taking the larger exponent and subtracting the smaller one. Alright, so here is a similar example, but this time the larger exponent's on the bottom. But the statement I just made is still going to work. If we take our larger exponent, which is our 8, we subtract our smaller, we'll get our final exponent answer, but we need to keep track of also where this answer needs to be. Since the n to the fifth power is smaller, it kind of moves down here to the bottom, to the denominator, and when that happens, we have an n negative 5. So when I use the product rule to combine these two, we see in the denominator, we get our n to the third power, but we have left nothing up top. So we have to go back, fill that in with a 1. So we can always take our largest exponent, subtract the smaller, but we have to also keep track of where in the fraction that final answer needs to remain. And it's always going to be wherever the larger one was to start off, that's where our final answer will be. Right? Our larger power was on the bottom, so our final m answer with its exponent is on the bottom of the denominator. Alright, so here on to this one. What do we do if we have bases in the numerator and denominator and one of them negative? Well, we know that negative exponents always tell us to take it, do the reciprocal, so as to switch spots in the fraction, change signs. So when it gets up there, we have a b squared. We have a b to the fourth. So when using our product rule, we have the same base. We're multiplying, add the exponents, we'll get a b to the sixth power, right? And it's in our numerator because that's where our largest exponent was. And also you can even try the 2, which is our largest exponent. If I subtract our smaller exponent, which is the negative 4, right, and we're subtracting a negative, they turn into a positive, and the 2 plus 4 gives us that 6th answer. So that approach also works as well. Alright, so a final example of how you can see the quotient rule is what if they are both negative? And what I recommend on this is go ahead and take the reciprocal of both of these terms. Get both of your exponents to be positive before we try to operate with them. And this just helps avoid confusion in dealing with the negatives. Because once I use the reciprocal, get them switched into this form here, now we're going to just do our quotient rule. I have r to the fifth power up top. When I subtract that r to the third power on the bottom, we would get the r squared left over up top.